and machine-based manufacturers which begin in the 18th century under the British system. It also impacts in the operational management, which was profound, shifted from homes to factories, which introduces the specialization and the mass production, and of course mainly focus on the management structure for the coordination and control system. This also leads to an operational challenges such as managing a concentrated workforce or manpower, and accordingly deal with the social economic consequences of the industrial system. Let's talk about the next section, that's called the history in operations management. It begins from the craft to factory system, where the industrial revolutions deal with the goods which was often produced in small batches in homes and using the hand tools, and such shift from home to factories, it has been transited with the powered specialized machineries, created a need for the new methods of organizing the workforce. The next is emergence of management. It is very important as the industrial revolution faces an operational challenges, and it would be mainly concentrate of labor in factories, which was required to create a new management structure. Specialized and coordinated work which always been regulated by the supervisors and managers, which leads to a foundation for modernized management principles. The next is mass production. The use of machines, particularly of the textile industries, where the new inventions like the spinning jenny, which enabled the, you can say, mass production of the products, and such increment in volume and the different varieties of the products could be produced at a lower cost, which also leads to an operational challenges like the poor working condition, where the working hours would be more for the laborers, and it could be difficult to manage them all collectively. The next is the industrial and the technological advancement. Innovations like the James Watt's, which has been invented a steam engine that's ultimately critical for the powering machinery, and it also improved the transportation system, where the efficient movements of the raw materials and the finished product would goes on smoothly, and that could be a core function of the operational management. And the last is the economies of scale. The factory system has always allowed the business to operate on a larger scale, which leads to a lower production cost, which introduces a major concept called economies of scale, and that economies of scale would also play a very significant role or a central theme of operations management. So now we'll begin the four main industrial revolution. One, industrial revolution. Two, or in other words we can call industry version 2.0. Then the next would be the industrial revolution 3, or industry version, that is 3.0, and the last one is the industrial revolution 4, that could be in the modern era, where the different technologies has been emerged or invented, like artificial intelligence, cloud computing, big data analyst, etc. So let's have an overview of all these industrial revolutions or industries versions 1 to 4. Let's begin with the industrial revolution, that is version 1.0 or industry 1.0. The first industrial revolution and the industry 1.0 technology, it refers to an era of the mechanization which begins in the Great Britain around the late 18th century. This version is diverged by the water steam power which transited the production from the manual labor to the machine based processes, and it invented you can say a great you can say instruments like the steam engine and the spinning jenny, where the spindle or you can say of the cloth or you can say wool etc took place. This also leads to a mass production and plays a significant role in the economic and social systems like the rise of the factory systems or the urban centers. Characteristics of the Industry 1 or the Industrial Revolution 1.0. In the late 18th century to mid 19th century, the Great Britain, this first revolution took place in the Great Britain, and then it also spreading in the United States as well. The primary energy source, it could be the water and the steam power for the transited from you can say from the handlooms to the factory system, the machinery systems, and which leads to an effective you can say manpower. The mechanization of production moving from artisanal and the more home-based work to factory-based mass production, because ultimately the traditional methods would be the home-based products, and in this era it was transited to the factory-based mass production. The major technologies has also been invented which called a steam engine and a power machinery along with the innovations like the spinning jenny and the power loom system. The affected industries, it could be the textiles, mining, glass, iron production were one of the first to be transformed in this era. Social and economic impact, it leads to the growth of the cities when we talk about the urban centers, and where the centers is also shifted from the rural to urban for the factory jobs, and ultimately it created a shift from the agricultural to the industrial economies. The major inventions and discovery of the Industrial Revolution 1, it shift from agrarian hand production economies to the industrialization and a machine-based manufacturing. And the key invention under this era are the textile, steam power, and the metallurgy. So these are the inventions, and who has invented these inventions in the Industrial Revolution version 1.0, and what would be the impact of such invention socially and economically. So the first invention is the improved steam engine, which was in the year 1776 and originated by the James Watt. Then again the spinning jenny, it was you can say originated in the 1764 by the James Hargreaves. And the next is the you can say water frame in 1769 along, which was originated by the Richard Arkwright. The next is power loom and so on, cotton gin, you can say puddling and the rolling, which was originated by the different inventors, and of course in the respective different years, and it surely been affected economically and socially to the you can say into the generations or to the traditional generations of the old era. Next is the steam locomotive in 1814. It's originated by the George Stephenson, and the last one is the telegraph and the Morse code, which was originated by the Samuel Morse in 1837. And have a following impact on the free movement of the raw materials and the finished goods. And of course, when we talk about the telegram, is a long distance communication with the uh, you can say interested parties. The negative shades of the Industrial Revolution 1.0. The first one, with the poor working condition is always exist, where the long number of hours has to be worked on in a week in the factories, which leads to a dirty, poorly ventilated and a dangerous conditions. The next is child labor, the exploitation of the child, which also a major issue, which they were paid very little and face a significant health conditions or risks. The next one is the urbanization and the sanitation issues. Is a rapid migration from the rural to urban areas due to the industries has been constructed and developed and shifted to the urban areas due to a poorly built housing facilities, inadequate sanitation systems, contaminated drinking water in the rural areas, and which ultimately leads to a frequent outbreaks of the disease like cholera and the typhoid. Next is environmental degradation. So widespread burning of the coal for fuels, it leads to you can say smoke pollution and the acid rain. So such industrial waste which also dumped directly into the rivers or the streams, which leads to a water pollution and habitat destruction. Next is a wealth inequality. The factory systems and the mass production is always enriched a new class of the factories owners and the new entrepreneurs, or you can say existing entrepreneurs. But while working class, which also face a major you can say issue, and ultimately they have to live in poverty with the little job security. The next is displacement of the skilled workers. The introductions of machines like the power loom, which also displaced the skilled craft people who have no longer to compete with the speed and efficiency in this particular machines. So unfortunately, the efficiency of the factory production is also you can say increases, but it also decline to the skilled craft person efficiency. And of course, it automatically impact on the trade union movements as well, which keeps on rising. Now we can come up to the next you can say revolution, that's called the second industrial revolution or the industry 2.0. The second industrial revolution was characterized with the development of electricity, mass production like the assembling line and the internal combustion engine. Their major inventions has been you can say come up in this era, like the light bulb, telephone, automobile, airplane, radio, which significantly transformed the transportation, communication and industry through the emergence of the new technology, which leads to an efficient manufacturing processes. This era is also saw a major you can say negative shades in terms of chemical like synthetic dyes and the plastics as well. The technologies which has been invented in the industrial revolution era 2.0. The first one is electricity. It's provided a new and efficient power source for the factories and homes, which also leads to a longer working hours, and the development of the new machine could also be more invented. The next one is the assembling line. It also introduced by the Renson E. Olds and perfectly perfected by the Henry Ford, and such system is also leads to a mass production and ultimately increases the efficiency. Next is the internal combustion engine, it also replaced to the steam engine with the more portable and the efficient power source, and which also crucial for the development of the automobiles and airplanes. Next is you can see the steel production, where the advanced you can say methods could be used for producing the steel. It could be in a cheaper rate, which is widely available you can say in that era, which leads to a construction of the larger buildings, bridges and the railroads. Chemical synthesis, the development of the synthesis dyes and plastic was also open up a new industries and the products in the second industrial revolution. Mass production is also enabled by the assembling line, which uses a specialized labor and interchange parts to produce more goods at a larger scale. Electricity is also refers to a powers a new machinery, lightning and other innovation which is exist in this era. Major inventions and discoveries during the Industrial Revolution 2.0. The first one is a light bulb. It was invented in 1879 by the Thomas Edison. Telephone, which is patented by the Alexander and the Graham Bell in 1876. The next one is the internal combustion engine, was developed in the 1880s. Then it comes to the automobile, that is the first mass produced model, which is appeared in the early 1900. Next is radio, was invented in 1895 by the Golgino Marcont. Let's come to the next Industrial Revolution 3.0. The third Industrial Revolution, or in other words, we can say a digital revolution from 1970 to early 2000, was defined to a integration of electronics, information technology and automation into the manufacturing processes. It also enables a partial automation and a shift from analog to digital systems. The Industry 3.0 technologies. What was the technologies invented in industries or Industry 3.0 or Industrial Revolution 3.0? The first one is electronics. The development of the semiconductors, transistors, microchips and integrated circuits was also being invented in this era, which leads to a smaller, cheaper and more powerful electronic devices. Next is the computers and information technology, and in short we can say IT. Computers has also become a significant part of the operations management in case of the automation and the control in the industrial settings, and later on it expand to the offices and households. Next one is the automation and robotics. The use of the control systems like programmable logic controllers and early industrial robots is also allow the industries to use or to perform the machines into a repetitive and hazardous task with a high precision and reducing the human manpower. Next is software and the programming languages. The introduction of the computer programming languages like BASICs in 1964 and the software for monitoring and the controlling production processes has also plays a very significant role in this era, and the various examples could be the computer aided design, the computer aided manufacturing, or the CAD or CM were also crucial role to play in this era. Next is the telecommunications and networking. Advancement in the telecommunication, including the fiber optics and the development of the internet, thrived on early networks like ARPANET, which enables a faster data exchange and communication across the globe or distances, and also it also facilitates the globalization of manufacturing processes too. Next is the new energy sources. The exploration and the use of the nuclear energy is also emerged during this period, because there was also growing interest in the development of the renewable energy technologies like the solar wind power, which also needs to protect the environmental pollution, and it also plays a major role to mitigate the environmental concerns. What are the major inventions and discoveries in the Industrial Revolution 3.0 or Industry 3.0? The first one is the integrated circuit and the microchip. It is late 1950, the first industrial robot introduced by the General Motors in 1961, the computer aided design and manufacturing, the Internet and World Wide Web, where the Internet development begins in the late 1960s, and the World Wide Web was introduced later. Next is also the personal computer, the first commercially available in the 1970s. Programmable logic controller, it was being originated in the early 1970s. Fiber optics is also invented in 1950 and later redeveloped in the 1970s. Biotechnology advancement is also took place in this era. 3D printing and additive manufacturing, it was early forms emerged. Mobile devices eventually leading to a smartphones. Solar batteries and the panels, the first invented in the 1950s, and it's widespread to adopt as a part of the renewable energy, where the moment later in the revolution. And the last industrial revolution is the fourth industrial revolution, and it also called you can say Industry 4.0, which leads to a significant transformation in manufacturing and the mass production processes, driven by the integration of the advanced technologies like artificial intelligence, the Internet of Things, big data, robotics, and the advanced analysts. And it resulted into a highly connected, automated, and the data-driven factories, which optimize the productivity, efficiency, and the flexibility across the supply chain management system. Origin and the development of the fourth industrial revolution. The term Industry 4.0 was also popularized by the German government and highlighting a new era of the industrial transformation. It also considered the next step in the evolution of the manufacturing, followed by the first, second, and third industrial revolutions. What are the core technologies of the fourth industrial revolution? The first one is the Industrial Internet of Things, that's called in short IIoT. It connecting the physical machines and sensors to the internet, allowing a real-time data collections and analysis. Cyber physical system, it refers to an integrated system that combines the physical processes with the digital information, enables the seamless communication between machines and system. Next is the artificial intelligence and the machine learning. So it also utilize the AI tools to analyze the data and make the intelligent decision and optimize the production processes system. Next technology is a big data and analyst. It's collect and analyze the large amount of data to gain the insight, and it also uses for a meaningful decision making. And the last one is the robotics and the automation. It also implements the advanced robotic system for the automated tasks either in the household or industries. It also includes the material handling, assembling, and the quality inspection in all. The next one is the benefits of industries, that is 4.0 or an industrial revolution 4.0. It increased the productivity and efficiency. So by automation or using the various technologies like CAD or CAM, it optimized the production. And industry 4.0 aims to improve the productivity and efficiency. Personalized production. It also enables the customized product based on the industrial or you can say revolution, and depends upon the individual customer preferences, and it enables the mass customization. Improved quality control, real-time data monitoring and analysis. It always allow the early detection of the quality issues and accordingly take a preventive measures regarding the maintenance. Enhanced flexibility, adapting production to the changing market demand and the customer needs with a greater you can say availability. Next is optimized supply chain management. It also refers to a seamless integration of the different stages of the supply chain, which leads to a faster delivery times and reduced costs. The challenges of Industry 4.0 at the present era that called a high investment cost, as the various advanced technologies has been invented in this era. It leads to a higher investment cost where technologies could be very expensive, and it plays a significant upfront investment in the hardware, software and infrastructure. The next is the cyber security concern. Increased connectivity in Industry 4.0, it also creates a new vulnerabilities to cyber attacks and requiring the robust security measures. The next one is a skill gap. The transition to Industry 4, which requires a new skills and training for the manpower, and it has a potential to create a gap between the existing skills and the required skills. The next is the data privacy and ethics. It also concerns or refers to various concerns related to data collection, analysis, usage, especially in terms of the privacy and the ethical factors. The next concept is a big data. Big data refers to a massive, a complex data sets that are proceed to uncover the hidden changes and insights. It was characterized by the fifth VS, that's called 5 VS, such as volume, velocity, variety, veracity and value. The applications of the big data analyst includes the market prediction and the customer behavior analysis. It also refers the tools and methods which will use to predict the market trends and analyze the customer behavior in terms of using the products. So this is a difference between the big data and business intelligence. So one of the main purpose of the big data is discovers a new challenges, a new opportunities, a new insight, which ultimately leads to improve the customer experience. Business intelligence is aims to monitor the performances and answering the major business queries and concern. What would be the data type in both areas? So in case of the big data, unstructured and the structured data would be processed. It could be through the social media, it could be through the videos or the transaction records. But business intelligence is totally dependent upon the structured, you can see, data. That means the data from the data warehouses. Next is processing. Big data uses the new tools like HADOM or the NORGL databases in order to analyze the real-time data. But in case of the business intelligence, it uses the traditional tools like OLAP analysis, which refers to a historical data. And the next is questions. The particular big data, it refers to a why and how the particular usage, the variety, the velocity has been come up. But in case of the business intelligence, what and where the particular data will be used and how it will be reported, in what way and where to be reported, that to be summarized. Relationship. Big data analyst can enhance the business intelligence, which makes it more powerful, insightful. But in case of the business intelligence, it can use the big data to make it reports and dashboards more comprehensive. Characteristics of big data. It refers to 5 V's, that's volume, velocity, variety, veracity, and value. So the volume is a sheer size of the data that is collected and stored. It could be large, it could be very hefty amount of data. Next is a velocity, the speed at which a new data is generated and need to be processed in real-time settings. Next is the variety. There are different types and the formats of the data. It includes structured, unstructured, semi-structured data, like the images, the content, and the video. The next is a veracity, the trustworthiness and the accuracy of the data. It leads to a veracity, where it could be a challenge, which because the data will be collected from the multiple sources. Next is value, the usefulness of the data for business operations and decision making would be an ultimate goal of the big data. What are the applications? The first one is healthcare. In case of the healthcare sector, big data is always predict the patient outcomes and the personalized medicines as well. In case of the banking and insurance, it detect the fraud and manage the risks. Entertainment, it recommend the content which could be necessary in terms of analyzing and personalizing the user experiences. Next is e-commerce and marketing. Big data target the advertising and you can say analyze the customer behavior. In case of the manufacturing, it helps to optimize the supply chain and predict the equipment failures. What are the challenges of big data? That would be the four main challenges. That is data privacy and security. It is very important to protect the sensitive user information, but hence the big data is also faces a challenges with the major regulations regarding the safety and security of the user important information. The next is the data quality. It handles the inconsistent, inaccurate, and incomplete data. If it happens, then how the tool called a big data or a technology called a big data will compete with it. The next is storage and processing cost, the high cost of infrastructure and the computational power required. Next is the talent gap. A lack of skilled professionals is also being available to analyze and manage big data. It could be a major challenge in it. What is the scope of the big data? The scope of the big data is vast and it continues expanding as technology, you can say, evolves and more data is generated. It also requires the development of a new processing tools and architectures which are open, adaptable, and can handle a diverse data type. It also includes the growing need of automation and self-service analysts to make the data more accessible to the public. What are the benefits of big data in operation? It enhances the operational efficiency. It increases to identify the inefficiencies, the bottlenecks, the areas for the improvement within the internal processes. Next is a cost reduction. In order to identify the wasteful practices, optimize resource allocation, the companies can achieve a significant cost savings in this area. So, for example, logistic companies can use the analysts to optimize the delivery route and reducing the fuel consumption and transportation cost. Next is the predictive maintenance. In case of the manufacturing and the mass production processes, the industries with the physical units, the big data, you can say from IoT centers can protect the competitor failures before they occur. Next is the supply chain optimization. It also provides end-to-end visibility across the supply chain processes. In this case, the predictive models can also be adopted to analyze or to predict the historical sales data, market trends, external factors like weather, etc. Next is improved product quality and consistency. Manufacturers can use the data or big data gathered throughout the production process and the spot trends, and you can see the anomalies, you can see impacting quality. It also allows the real-time adjustment and the faster root cause analysis for the issues in the quality and consistency. Next is the real-time decision making. The high velocity of the big data allows the organizations to process and analyze the useful information in the real-time settings. Enhanced risk management and fraud detection, and ultimately by analyzing a vast data set, businesses easily identify the unusual patterns indicated or the potential risk or any fraudulent activities. Next is the workforce productivity. Big data can also improve the productivity by revealing the insights into workload patterns and performance matrices. The next concept is the cyber physical systems. The cyber physical systems are the integrations of how the computational networking and the physical equipments could design to monitor and control the physical processes through a feedback loop. The primary aim of such system is to enable the intelligent automation, optimization, and hence the decision making across the various industries. What are the objectives of the CPS? That means the cyber physical system. The first one is optimize functionality. It streamlines the operations and improve the efficiency of the physical systems. Next is enhance autonomy. It also enables the machines and systems to make an impactful decisions and adapt according to the changes market conditions. Next is improve the reliability and safety. It also increase the dependability of systems, especially in healthcare sectors and the transportations, where the failures would almost more chances to face major consequences. Next is increase usability and the adaptability. There are various large scale organizations where the complex system or large scale systems would lead to a more flexible and easier to manage, and such systems would also adapt to a new requirements in environments. Next is bridge the digital and the physical world. It refers to a seamless integrated computable you can see components and the physical processes to allow a real-time interaction and feedback, and it all in this way it also leads to a new inventions like digital twins for simulation and design. Areas suitable for the CPS application. The first one is the manufacturing, the smart factories and industrial automation in case of Industry 4.0. Transportation, autonomous vehicles, intelligent traffic management systems, and other tools would be used in it. Healthcare, medical devices and the pacemakers, insulin pumps, its remote patient monitoring and robotic surgery is also the new technologies which also been emerged in Industry 4.0. Next is energy, smart grids, power generation, efficient energy distribution management is also being emerged. Civil infrastructure, the smart buildings, water and wastewater management, public safety system is also took place in this era. Agriculture, precision farming including automated irrigation and monitoring of soil crop condition. Next is the aerospace and defense, drones, flight control system, complex defense mechanisms is also being you can see a part of the cyber physical system. The next concept is a mobile cyber physical system. Mobile cyber physical system are the subcategory of the cyber physical system where the physical system under study has inherent mobility, or the computing elements are transported by the mobile agents that could be the humans or animals. The rise of the smartphones has also been increased in this era, which leads to a powerful computational resources, multiple sensors like GPS, cameras, etc., and the communication mechanism Wi-Fi, 4G, 5G or Bluetooth. It always exists in the mobile phones, and you can easily track the location of any person if the chip has been attached in it and through digitally on your mobiles. Applications for the mobile CPS, the vehicular networking system. It collects the real-time traffic information from a fleet of mobile devices like taxis in the MIT Cartel project to calculate the fastest routes or to detect the accidents. Preventive healthcare, using the wearable devices, mobile phones to continuously monitor the patient vital sign or emotional states, providing a timely personalized interventions. Mobile education, it also developed the educational applications that could use the sensing capabilities of the mobile devices to help children and interact with or learn about the physical world in the real time settings. Application of the CPS, that is cyber physical system, the smart manufacturing, the real-time monitoring and controlled of production processes where the robotics, connected machineries, artificial intelligence will be used to predict the maintenance and the quality control. Next is the automated vehicle. It also refers to a self-drive cars and the trucks which uses the sensors and other mathematical models to navigate and make decisions early. The next one is the smart grids. It utilizes the sensors and the communication networks to optimize the flow of electricity and integrate the renewable sources and prevent outages. Next one is the medical monitoring. It refers to plantable and the wearable devices that monitor the physiological parameters and automatically adjust the therapy that's called the insulin pump. Building automation, the smart buildings is also uses the CPS to control the HVAC lighting security systems to improve the energy efficiency and safety. And the last one is the traffic management, adapting the traffic signals. You can adapting you can see meaningful traffic signals and systems that optimize the urban mobility to analyze the traffic flow data in the real-time settings. Next is Industrial Internet of Things, that's called IIoT. So the Industrial Internet of Things is a foundational and the critical technologies components for Industry 4.0, which also provides the seamless connectivity and real-time data exchange to create the smart factories and drive a digital transformation. It acts as a data collection and communication infrastructure within a broader prospect, and it also implements a conceptual framework of Industry 4.0. What is the role of IIoT Industry 4.0? The first one is the real-time data collection and analysis. It senses they generate the massive amount of data on machine performances, environmental conditions like temperature, pressure, vibration, production matrices in real time. Next is a predictive maintenance. It also helps to monitor the machine data and predict the potential equipment failures before they occur. Next is the automation and operational efficiency. The insight gained from the IIoT data enables increased automation and optimize the industrial processes, which leads to a higher productivity, reduce the human error, and improve the resource utilization, or in other words, we can call the energy management. The next is smart factories and cyber physical system. IIoT is also refers to a core technology that powers the smart factories where the cyber and the mobile physical systems always exist with the computational and the communication capabilities. The next is the supply chain optimization. It also provides the end-to-end visibility across the supply chain through real-time tracking of goods and materials, which leads to a better stock management processes, efficient logistic, and of course reduces the lead times. Next is enhanced quality control. The data generated using IIoT sensors, it helps to monitor the production parameters and detect the changes or the defects in the real time. It which ultimately improves the to take a quickly corrective action and improve the overall product quality and the consistency. Digital twins. IIoT data is used to create and maintain the digital twins. It refers to a virtual replicas of the physical assets or the entire production lines. These models are also used for the simulation and testing of the changes without disturbing the actual operations. Next is augmented and the virtual reality. Augmented and virtual reality AR or VR technologies of Industry 4.0 creates immersive experiences by either adding digital elements or to the real world or replacing the real world with a simulated one, that is virtual reality. They have a wide range of applications and implemented through the various forms and method. What are the applications of the virtual reality? The first one is the entertainment and gaming. The most common application providing the fully immersive and gaining experience like 3D cinema, 5D cinema, and a virtual theme park rides. Next is education and training. So it is also used to simulate the real time scenarios for training in the fields like military exercises, pilot training, etc. Next is the healthcare and therapy. It also utilized the surgical training, the pain management, physical rehabilitation, exposure therapy for the phobias, etc. Next is a real estate and architecture. It also enables the virtual tools of properties or 3D visualization of the architectural designs before construction. It also saved the time and cost as well. Travel and tourism. It also offers the visual exploration of destination or the landmarks for those unable to travel physically. Next is engineering and design. It also allow the engineers to see and test the virtual prototypes before creating any new physical products or physical system to speed up the design cycle. So in this way, how it would be contribute to the you can see the real and the augmented and the virtual reality. So there are various elements. It could be engineering, design, travel, tourism, real estate and architecture, healthcare sector, which ultimately these areas or discipline which always helps to get an insight through the 3D using 3D visualizations or before you can see constructions in you can say designing the construction sites, in designing the virtual you can say visual designs for the buildings, and accordingly it helpful to you can say generate the apps for to travel the destination, to identify those areas where for the individuals where the travel physically would be impossible. It also such augmented and virtual reality tools of Industry 4.0. It also allows the engineers to look into the virtual prototypes before launching any new physical system, because when we talk about the prototypes is all about to create a simple versions of the products and services to get a review from the customers before it launch. So it would be good to receive a feedback before launching or creating any physical items in order to speed up the any design cycle of a building or any construction site. So in terms of the travel and tourism, it also offers to explore different destinations or the landmark for all those people who are unable to travel in person. So in some cases there also are various applications which also exist in the industrial revolution 4.0 under the augmented and the virtual reality, and the few aims of such tools is to give the technologies that have various and advanced technologies so that the industries and the enterprises could use safely for the society and for the and to show the economic impact in the on the economy. So in the first one is the entertainment and gaming. So the most common application when it comes which gives a fully impressive gaming experiences to the youth, like the 3D cinema or 5D cinema or any other virtual theme park rides, which is so shows an amazing experiences to the youth, and it could be could be, you can say, where the individual could visit to any of the virtual theme park, you can say, places or destinations. The next one is the education and industry. It is also used to look up the real world scenarios for the training purposes in the various fields. It could be the defense or military, the pilot training, the occupational therapy, or the safety measures without looking up the real world consequences. But in terms of therapy, it also plays a very important role where the physical rehabilitation systems, you can say, or the centers are available. But through these technologies, the person who are sitting at home, they can also utilize these sort of training in terms of surgical training, pain management training through the use of virtual reality, so that it could be constructed, and such training could be constructed under the controlled environment. So it could be better to use all the application according to the usage of the individuals, and of course the industries utilize these tools in today's scenario, where the advanced technologies could be used according to the preferences by the various industries like textiles, cotton, garments, fintech companies or organizations could also be used in the respective areas and disciplines. So in this applications, such tool could be used securely and safely in the real time settings. But when we talk about it, how you distinguish between the augmented and the virtual reality. So the main difference of the augmented or the virtual reality technologies, that it gives a amazing experiences either to add on any digital elements in the real picture of an individual, or a real picture of any equipment, or replace the real into a, or you can say, simulated one, where the online videos could be useful, where the particular trainings are to be provided to the any you can say individual or any main force, so that the trainings would goes on, it cannot be mitigated in any way. So it's all about the technologies, it's all about that how a particular individual add the digital elements in the real picture, in the real world, and how it replace that real world with the virtual form. And that would be the main difference between the augmented and the virtual reality technologies. And these tools or these technologies is also being used in the various applications, and it could be implemented according to different forms and methods. As I already explained, it could be through the gaming and entertainment, it could be the healthcare and facility, it could be any other sectors which is being the augmented and the virtual realities are to be, such technologies are to be used in different disciplines and areas accordingly. And every industry has a significant role and use these applications of such technologies according to the preferences, according to the usage, according to the need. So so the work would goes on, rather than to mitigate the activities, the operational men force or operational workforce in the real time settings. So it happens on the time period, it happens on the real time periods, then how the industries use these technologies in a more effective and efficient manner. So in this way, these technologies will be used, and how it add on the digital forms to the real world, which gives an amazing experiences to the industries and the workforce or the manpower who are working in these industries. And it could be useful into various applications to various disciplines as well. So they could be converted into any form, either digital or to simulated ones through the visual forms. And our industries have a various technologies that how they could mitigate the risks. Either could be the political, it could be the legal, it could be a technological risk as well. So through this, it could eliminate such risks and work into a digitalized manner. That's it for today. Thank you so much for listening this lecture. I will come up to a more and more interesting and relevant topics in the upcoming session. So till time, thank you and namaste to all.